Hi, so welcome to just Sigma Math, and in this video lesson we are going to be taking example as touching conservation law of mechanical energy. So if you have not subscribed to this YouTube channel, if you are new, kindly do so by subscribing to this YouTube channel. All right, so we have a question. Let's say that a ball of mass 2 kg falls from rest from a height of, let's say, 200 meters. Then this is the ground level. Then calculate its kinetic energy after falling a distance of 50 meters. So that means after falling a distance of 50 meters. That means this is the maximum height. This is the maximum height. So therefore, we are saying that from here to here is 50 meters. Okay. All right, good. Then the 200 meters is from here to here. All right. So just from here to here is 50 meters. So what is the kinetic energy used up? Okay. Now, one thing you have to know is that at this point, the kinetic energy at this point, that is the maximum point, is actually 0. Why? Because at maximum, the velocity is actually 0 because the ball is at rest. Remember the question said from rest, falling from rest, forced from rest. So rest, that means that the speed is actually 0. Okay, then the potential energy has to be a particular value, which we don't know for now. Then at the ground level, the kinetic energy is a particular value. K, let's call that K. We don't know. So at the ground level, the potential energy is 0 because it has no height. Okay, since that we've known that, that's beautiful. Okay, now can we calculate the potential? Can we calculate the potential energy at the top? Yeah, this K, can we calculate that? Yes, of course we can. So at the top, the kinetic energy, sorry, the potential energy rather, potential energy at the top, let me write that, at the top is actually equals to mgh, and that's the mass is 2 multiplied by acceleration due to gravity 10. Then what is the height? 200 meters. So at the top, 200. And so the kinetic energy at the top is actually that 4,000 joules. Okay, so that means at the top is 4,000 joules. That is the K. That is the K. 4,000 joules. So K is equal to 4,000. So that means at this point, now remember that the law of conservation of mechanical energy says that at any point, the potential energy plus the kinetic energy is equals to a particular value, a constant. Remember this law? Good. So that means at any point, potential energy plus kinetic energy is equals to 0. So at this point, what is that? So potential energy is K. Potential energy at this point is 4,000 plus 0. So that means that PE plus KE at this point is equal to 4,000 joules. Okay, good. That means it's going to be the same at this 50 meters mark. So that means PE plus KE at this point has to be what? Equals to 4,000 joules. So it's just a law. And at the bottom, it has to be what? PE, which is 0, plus kinetic energy, which is K, which is also 4,000, also equals to 4,000 joules. Now, the question now is that we are asked to find the kinetic energy at this point. What's the kinetic energy at this point? This point. So now I already said that this is the formula that we are using. Okay, good. Now, remember that if this ball is falling, if it has fallen 50 meters down, then what is the height here? That's a beautiful question. Now, since from the top to the bottom is actually 200, so if it falls 50 here, that means we are left with 150 here. So that means the potential energy, the height here to calculate the potential energy is actually 150. So potential energy at the 50 meters high is actually m. What's our m? The mass of this body is actually 2 kg. 2 multiplied by acceleration due to gravity multiplied by the height 150 meters. So that is the height from the ground level to where this body is 150. Okay, so that equals to 300 as 3000 joules. Now recall, can we bring this here? So that means the potential energy at that point 50 plus the kinetic energy at point 50 is equals to a constant which is 4000 joules, right? I think this is it, 4000 joules. All right, good. Now we've calculated for the potential energy at that 50 meters mark. That's 300,000 joules. And we have to calculate the kinetic energy at the 50 meters mark now, and that is equals to 4000 joules. All right, so we can find the kinetic energy, and that's 4000 joules minus 3000 joules, and that gives us what kinetic energy equals 1000 joules. So at 50 meters, falling 50 meters. So after falling 50 meters, so this is after falling 50 meters towards the ground. So this is the answer to that question. All right, good. So have a nice day, and this brings us to the end of this video. If you have not liked and liked and subscribed to this YouTube channel, please do so, because it doesn't mean anything to you, it doesn't cost you anything, but it means a lot to me. And also share it to people that might probably need this video lesson. Thank you very much.